dealing with a bunch of what we call angle pairs. These are relationships between angles. What you're going to be using this for is to decide when you're solving an equation whether you are going to be setting them equal to each other. That's one option. Whether, bless you, you're going to be adding them up to 90, okay? Or if you're going to be adding them up to 180. That's what you've got to decide. That's what you're going to be using these for to solve with. Setting them equal, adding them up to 90, or adding them up to 180. And we're going to use all these definitions to get there. You're also going to have to be able to identify these. So let's start looking through these. The first ones that we're going to be dealing with. Okay? The first ones are going to be called adjacent angles. Guys, when you live adjacent to somebody, you live next to somebody. It's the same idea here. When you have adjacent angles, they are right next to each other. Okay? We're going to take care of the formal definition first, and we'll go from there. This is going to be two angles that share a common vertex and a common side. That's not an M. I'll get it. Hold on one second. Common vertex and a common side. A common vertex and a common side. That's perfect. Thanks. Good deal. We're just getting started on notes. We're on the very first slide, so you're good. Okay. Here we go. It's got a common vertex and a common side. There's a but, though. There's always a but in math, guys. There's always an exception to the rule. Okay? But no, and I would underline this, no common interior points. Okay? Now, I'm going to read through it again. We're going to talk about what it is, and then we're going to go through and identify and do this stuff down here. Two angles that share a common vertex and a common side, but no common interior points. Guys, what that means, the no common interior points means they don't overlap. No overlap. There's no overlap. That's the key to that part. No overlap. Okay? No overlap. Now, being able to identify the common parts that are on here, we've got to make sure we know that. We've got to see the adjacent angles. So we're going to start with this pair right here. I'm going to put some letters on here. Take a minute and put these letters on here. We're going to name it E, F, G, and H. Take a minute and put those on there. E, F, G, and H. We're going to use them to identify stuff, guys. So E, F, G, and H. I'm going in this order, just so you can see, because that way you can identify. From left to right, E, F, G, and then H up in the air. Yep. The only reason I'm putting those on there is so we can name which one is the vertex and which one's the common side. So guys, looking at these, what's the vertex that both the angles share? F. So F is going to be your vertex. The common side would be a ray. What ray is in between the two angles? I need a ray that's in between the two angles. This is the common ray. Guys, I'll highlight the angles in different colors just to help people. Let me go ahead and get this a little bigger. Okay, I'm going to put one on this side. Here's one angle. But do you see it overlaps with this angle right here, how they share that common side? You see which one's common now? So the common side would be ray what? FH. Perfect. FH. That would be the common ray that they share in between them. So these two angles, angle 1, and that's an and symbol. Bear with me, guys. I'm writing with this stupid pen. Okay? Angle 1 and angle 2 would be adjacent to each other. They share a common side. They share a common vertex. They are adjacent because they share that common side, guys. They're right next to each other. Okay, on this next one, tell me what the vertex is that they share. What's their common vertex? B. And then the ray that's in between them, the ray they would both touch would be ray what? BC. Nicely done. BC. This one in the middle is the one they have in common. This one is the one that's shared. This one right here. That's the common one. They both touch that. Now we got to name this by 3 letters. There's no numbers inside it. This time we got to use the letters to name it. So what angle is the angle that's on the top right here? Oops, sorry, I changed the wrong thing. Hold on 1 second. This angle right here in pink, what angle is the pink angle? ABC. And it would be adjacent to this angle that's here in, let's do red. Let's see, I gotta change the highlighter in red. Sorry, here we go. This one in red right here. What angle is the one in red? CBD. CBD. There we go. Say it one more time. What do you mean by that? It could go DBC. It could go backwards. It can have B anywhere but in the middle though. That's a very good question about can it go any other way? Yes, but the B has to stay in the middle. Guys, whatever's the common vertex, this one has to be the middle letter. Has to be. Doesn't work if the B's not the middle letter. Okay? Okay, guys. Just the concept of adjacent angles. The only thing I need you to get out of that is being able to...
Is this Ms. Rayleigh's
Yes, yes, it is.
Sabria Cloud is being signed out.
Yes, ma'am. Sabria, come grab this so you don't have to deal with it later. It's already printed for you. There you go, sweetie. And then I've already posted the video so you can find it on there. Okay? Okay, guys. Okay, so what I need you to get out of this is being able to identify adjacent angles. They're next to each other. You got to be able to identify that side they share and that common vertex. There's nothing to do or solve equations with this. The whole idea behind this is just they're next to each other. That's it. Adjacent means next to each other. Any questions? Okay, let's keep going, guys. Here we go. See you later, Shay. I'll see you on Thursday or later, depending on what happens. Now, complementary and supplementary are 2 terms that are supposed to be from your previous skills. They are in the 8th grade and 7th grade skills, but a lot of people come here with the wrong information on these, so I teach it like you've never seen it. Complementary angles are going to be 2 angles that add up to, anybody know the answer? 90. Complementary is 90 degrees. Complementary and guys, it goes alphabetically. Complementary comes first, supplementary is last alphabetically. The complementary are the smaller ones, supplementary are the bigger ones. So 2 angles that add up to 90 degrees. Alright, and 2 angles that add up to 90 degrees are going to be right here in this picture. Guys, how do I know this adds up to 90? I know because of this symbol. This symbol means that this is a right angle, and a right angle is 90 degrees. So angle 1 and angle 2 would be complementary to each other. If I was solving a problem like that, actually there was one on the homework last night, I think it was 2 nights ago. So if you have 2 that are on a right angle, then they are going to add up to 90 degrees. You would say like 5x plus 2 plus 7x plus 3 equals 90. The whole idea would be to add them up and set them equal to 90. Now, there's something unique about complementary and supplementary. They don't have to be adjacent to each other. It doesn't say anything about where they're at. So even if they're floating separately like this, as long as they add up to 90, they can still be complementary. So angle A and angle B are still complementary even though they don't touch each other. A lot of people struggle with that. A lot of people forget that just because they don't touch, they think they can't be complementary or supplementary. Angle A and angle B would also be complementary to each other. Okay. Supplementary. 2 angles that add up to how much? 180. Yes, ma'am. Absolutely. Give me 1 second. Let me get there. 180 degrees. Yes, ma'am. Yes. Yes.
So it got to equal to 90.
It has to equal 90 when you add them together. Say it one time.
They equal if they equal to 90.
Yeah, that's when they're complementary, when they add up to 90. And they don't have to be next to each other. They can be floating separately or they can be right beside each other. Yep. Guys, please ask me questions. Thank you. Thank you. If you have anything, please ask me. I would like to stop and answer your questions. Okay, here we go. Supplementary. Two angles that add up to 180. Guys, what shape have we already done that always adds up to 180? Straight lines. Lines add up to 180. So lines add up to 180. So if you see two angles that are right next to each other that form a line, then they're going to add up to 180 degrees and they are going to be supplementary to each other. So angle 3 and angle 4 would be supplementary, which means if you add measurements, you would say like one of them's 100, one of them's 80, they're going to add up to 180. Yes, ma'am?
I think 3 and 4.
Take your time.
I don't really understand that 180.
Okay. Every straight line on earth adds up to 180. That's actually from previous notes. So you may have missed those because I know you've been out a couple of days. So whenever you have a line anywhere on earth, ever, they always add up to 180. That's something you got to know. And that actually shows up like literally all year long. That's one of those things. I told you there's not really anything in this set. That's from previous set. Guys, 180 for lines adds up like you'll see that all year. Good. On the next one, how do we know that R and W are going to be supplementary to each other? Yeah, if you do 120 plus 60, it's going to equal 180. That's how you know they're supplementary to each other. If they add up to 180, that's how they're supplementary to each other. Right? Again, they don't have to touch to be supplementary. They don't have to touch to be complementary. Complementary angles add up to 90. Supplementary angles add up to 180. Questions? Good deal, guys. Okay. Wait, anybody still writing? Try to make sure. Okay, here we go. Next ones, vertical angles and linear pairs. Guys, vertical angles are probably the most common out of this. There's nothing really hard about them, but they do tell you something about how you set up the problems for them. So vertical angles are going to be two angles formed by intersecting two angles formed by intersecting lines that are across from, that's not the word from, let me try that again. The pen did not write from. Across from each other. I'll read through it again. I'll give you a chance to make it, write it down. Okay, it's going to be two angles formed by intersecting lines. They got to cross. The intersecting means they cross each other, guys. Two lines that cross through each other. Okay? And they are across from each other. That are across from each other. So when you look at this picture right here, one would be vertical to what other angle? 3. Perfect. 1 and 3 with a little angle symbol in front. Angle 1 and angle 3 are vertical to each other. Now guys, look at those two angles. What else do you know about vertical angles? They are always what to each other? Congruent. Very nice. They are congruent to each other every time. Which means if you're solving a problem on this one and you see vertical angles, you can set them equal to each other and solve a problem. Let's say this side was 2x and this side was 100. You could set 2x equal to 100 and solve it. They're the same. They're equal. Vertical angles, measurements are equal. They are congruent. The angles are congruent. Their measurements are equal. Okay. Now, if 1 and 3 are like that and they are vertical, what else is vertical in that picture? 2 and 4. Now guys, we can't put 1 mark on them because we already have 1 mark on 1 and 3, so we got to put 2 marks when we do these. 2 marks here and here, and we would say that angle 2 and angle 4 are vertical from each other. Those are vertical. Okay. Sorry, I saw an update, but it was just about emergency contacts. I thought it was an update like of closures. It was just an update of emergency contacts. Okay, guys, so when we look at this picture over here, what's vertical to each other? It's a trick question. I'm just telling you up front. Thank you for answering, but it's a trick question. What if I extend this line? 5 would actually be vertical to this one. It's not numbered. What if I extended this line? 7 would actually be vertical to this one, and 6 right here would be vertical to this one. Are any of those numbered? Not the ones across from them. So actually in that picture, how many are vertical? None. There are no verticals in there. None of those are vertical to each other. They have to be directly across from each other, guys. And I'm going to go back and erase this just so you can see it really quick. Guys, if I go back, I'll put it back up there, but I'm just going to go back and erase this real quick. Guys, look at this picture real quick. Do you see how 5 and 7 are directly across from each other? They have to be directly across to be vertical. I'll put the picture back up there. I just want you to see that. There you go. Okay. So, we got, I think, 2 left. This one in angle bisectors? Is that what we got left?
Yeah.
Okay, and then we got some problems to do. So, linear pairs. We're going to talk about what each one of these lets us do in these problems we do. So, for linear pairs are going to be 2 angles. Oh, don't have my pen. 2 angles that are adjacent Yes, 2 angles that are adjacent. Guys, all that means is they're right next to each other. Remember, that just means they're share common side, share common vertex. They're next to each other. Right? But based on this word, they're going to form a what? Line. They're linear. They're going to form a line. So 2 angles that are adjacent that form a line. Now, let's talk about it. Guys, if they form a line, how much are they going to add up to? 180 every time. Okay, they're going to be 180 degrees. And if they're 180 degrees, they're going to be what to each other? There's a word. We just learned it. It's in our notes. If they add up to 180, what are they? Supplementary. That doesn't quite look like mentary. Hold on. My E got lost. Supplementary. Alright. Linear pairs are supplementary to each other. They add up to 180. They make a straight line. So you've got to be able to name the angles that are supplementary to each other that make a linear pair right here. Make a line, 180 degrees. So that would be angle. Give me the one that's right here in blue. What angle is this? PQR. Perfect. Or RQP. I heard that also. Someone started with R. And what is the angle over here in red? RQS. Perfect. RQS. Angle RQS. Or SQR. Just putting it out there. Okay, on the next one, guys. Oh, guys, because they make a line, they add up to 180. That's the key. They add up to 180 when they make a line. That's we've actually done that before, but that's a linear pair. In this next one, guys, which ones are the linear pair? Heard somebody say it. They're not bold enough to say it loud. No. The answer is actually none. Because none of them actually extend all the way through and make a straight line. That is exactly right. If I extend these lines out, do you see any pairs that go on these lines? No, they're a little bit off. If they're a little bit off, it doesn't work, guys. They have to make a straight line in order for this to work. So in this picture, there are none that make an exact straight line. There you go. It'd be like if you put the straight edge up to the 2 of them. They make that straight line when you put it up for the both of them. Are all a little bit off, so you can't do that. Okay, guys. Last one is going to be, what is it? Angle bisector? Okay, let's talk about the angle bisector. We've actually already done this in some of our pictures. We just didn't call it this. I will tell you that angle bisectors are something you're going to see in what we call proofs later on. They use this segment bisectors and angle bisectors as something you need to know the name of. So this is something you definitely need to know the actual name of what it's called. So an angle bisector, first of all, guys, what does the word bisect mean? What does sect mean? Does anybody know what that means? Take apart, cut, section it up, absolutely. Usually it means cut is the actual translation for it. And what does bi mean? Two. So you're cutting it into two angles. That's exactly right. So it's going to be a ray, because the sector, the thing that cuts it in half is a ray that cuts an angle, because you got a at the front, a ray that cuts an angle into two congruent, we'll use the symbol, congruent angles. You can write the word or the symbol, guys, it doesn't matter. We've got the symbol, so I'll use it. A ray that cuts the angle, into two congruent angles. So looking at this picture, first thing we need to know is what is the angle bisector? Which one here is the ray, because we know it's a ray every time. What ray cuts this angle in half? B what? BC, perfect. BC is your angle bisector right here. You got to be able to identify that. Now, the two congruent angles that are formed, and you can see they're marked congruent. These little marks mean they're congruent, guys. You got to name what they are. Angle what is congruent to angle what? Let's see. What's the one at the top? ABC. Y'all are getting better at this. I'm naming the 3 points. ABC, what's the angle on the bottom? CBD. And those could be forward or backwards. Nicely done. Guys, if you were solving an equation with an angle bisector, you would set the two parts equal to each other. Set the two parts equal. Okay, guys, so I'm going to review my choices. Before we get to the problems, let's review the choices. You're either going to add things up and set them equal to 90, add things up and set them equal to 180, or you're going to set them equal to each other. Those are your only 3 choices. Okay, let's show you what our problems look like. Here we go. So this, guys, for some reason my examples, like example numbers floated away. Please number them, because you're going to need it for folder check. Please do that now. Examples 1, 2, 3, and 4. Don't know why they just, literally when I imported it to a PDF, they floated away. Yes? No, it was supposed to be tomorrow, but we're not going to be here, so. It was supposed to be tomorrow, but that is not going to happen. Okay, guys, here we go. So first things first, these two angles are adjacent to each other. They make a line, so they're going to be a linear pair. And in a linear pair, they're going to add up to 180. They're going to be supplementary and add up to 180. So my equation is going to look like this. 2x plus 24 plus 4x plus 36 is equal to 180. This is a matter of combining like terms. Our like terms are going to be the 2x and the 4x. And then we're going to combine the 24 and the 36. What do you get when you add the 2x and the 4x? 6x. What do you get when you combine the 24 and the 36? What was it? 60. Okay. Equals 180. To solve it, once you get the combining like terms, you're going to subtract 60 from both sides to get away from that variable. It's going to make it 6x equals 120. Divide both sides by 6. And what's x equal to? 20? Yes, no, maybe? Okay, I just want to make sure everybody said the right thing. 20. Everybody's agreeing on it. Does anybody have a concern, question, anything about it? Do I need to plug it back in? No, because all it asks me for is x. You got to know what you're asking for. They're asking for x in this case. Okay, here we go. On this next one, what would FL be called based on the stuff that's here? FL, the ray FL. Ray FL would be a what? It would be a angle bisector. How do I know that it's an angle bisector? Because it's inside an angle and the two sides are the same. It's split in half. Split, that's a good word. Split in half, congruent to each other, anything along those lines. Whenever you see it equal to each other, that's an angle bisector. Because of that, I can set these two amounts equal to each other. 7y minus 1 equals 55. I'm going to add 1. 7y is going to equal 56. No, I get 9 times 6 and 8 times 7 mixed up. This is 8, right? Y equals 8. 56 divided by 7 is 8. Okay, guys. So, the last two problems are based on those two problems. You need to make sure that you can do them. So I'm going to let you try to get some answers for me on those two. Try examples 3 and 4. Does anybody have a question on 2 before y'all work on 3 and 4? Okay. Let me look at this real quick. I got an email I got to respond to. Dean of Students. Y'all get those two done while I look at this email real quick. Answer some questions on here. Okay, got that taken care of. Let's see on the other one. Sniffling. I'm sorry, sweetie. Take as many as you need. Feel free to get as many as you need on there. Okay. Does anybody have an answer to example 3 yet? What is it? 6? Do y'all agree? Not agree? Oh, I got a little bit of agreement. We'll see on that. Anybody got one for 4 yet? Not yet? Oh, you got one? What do you got? You got 10? We'll see if we get some agreement in a minute. Let's get ready. 1 more minute. Finish up. Try to get those answers. Okay. Okay, guys, let's show you how it is. I just want to make sure because I'm going to give you some time to work. So here we go. 3x plus 32 equals, I'm going to get you, hold on, I was in the middle of the right. Who said that? What you got? For 4? 30? Anybody got decimal? Decimal. Okay, we'll deal with that. It's not a decimal, I don't think. What did you get? You got 10 also? I got some agreement on 10. Alright, we'll see. We'll get there. Let's check this one real quick. Here we go. We would minus 3x. That would make it 32 equals 6x minus 4. We would add 4. It's going to be 36 equals 6x. We divide both sides by 6, which means, 36 divided by 6 is 6 equals x. That one is correct. Does anybody have a concern? Any questions about why I did what I did? Anything on solving example 3? Okay, let's try example number 4. Guys, these are not equal. These are going to what? Equal 180. They're going to add up to 180. So here we go. 100 plus 9x minus 10 is going to equal 180. We're going to combine our like terms. Our like terms are going to be the 100 and the minus 10. What's 100 minus 10? 90 plus 9x equals 180. We're going to minus 90 from both sides. I'm guessing some people added it. I think that's where the 30 came from. That's going to make it 9x equals 90. Then when you divide both sides by 9, that gives you x equals 10. Is that what it was? I could tell once I saw that number, I saw that if you added it, it'd give you that answer. Question? Take your time.
So I added it.
Did you add 90 instead of subtract it?
I did not
Say it one more. You did 9x minus 90, is that what you said? That's where it went wrong. So the bigger number was positive. If you did it like this, I didn't even consider that as a possibility. Thank you for mentioning that.
Plus 9.
It should be plus 90 because the bigger number was positive. And that would change it to what you're doing. That may have been the same thing that she was talking about, but in a different form. Guys, y'all asking questions helps, guys. You're going to get this stuff figured out. Yes.
I put 90 times 2 before then,
Yeah, it's still gonna, that's perfectly fine. Thank you for mentioning that. It absolutely can go either one first. Anybody else? Good deal, guys. That's your notes for today. Good questions. Let's keep those up. From here, please go ahead and